This model of the atom may look familiar to you. This is the Bohr model. In this model, the nucleus is orbited by electrons which are on different energy levels, but it didn't always look this way. We will explore how a model uses familiar ideas to explain unfamiliar facts observed in nature, as well as how these models change as new information is collected. The atomic model has changed throughout the centuries, starting in 400 BC when it looked like a billiard ball. Democritus is a Greek philosopher who began the search for a description of matter more than 2,400 years ago. His theory claimed that matter could not be divided into smaller and smaller pieces forever. Eventually, the smallest possible piece would be obtained. He called this piece atomos, meaning not to be cut, to which we now refer to as atoms. This theory was ignored and forgotten for more than 2,000 years, until in the early 1800s, the English chemist John Dalton performed a number of experiments that eventually led to the acceptance of the idea of atoms. He deduced that all elements are composed of atoms and that atoms are indivisible and indestructible particles. He also explained that compounds are formed by the joining of atoms of two or more elements. This theory became one of the foundations of modern chemistry. In 1897, the English scientist J.J. Thomson provided the first hint that an atom is made of even smaller particles with his plum pudding model. The plum pudding model suggested that atoms were made from positively charged substance with negatively charged electrons scattered about, like raisins in pudding. Thomson also studied the passage of electric current through a gas. As the current passed through the gas, it gave off rays of negatively charged particles. Since the gas was known to be neutral, he reasoned that there must also be positively charged particles in the atom, but he could never find them. In 1908, English physicist Ernest Rutherford designed an experiment involving firing a stream of tiny positively charged particles at a thin sheet of gold foil. Most of the positively charged bullets passed right through without changing course. However, some of them did bounce away from the gold sheet as if hitting something solid. From this, Rutherford concluded that an atom had a small, dense, positively charged center that repelled his positively charged bullets. He called the center of the atom the nucleus and proposed that negatively charged particles were scattered around the outside. In 1913, Danish scientist Niels Bohr proposed an improvement to this model and placed each electron in a specific energy level. According to Bohr's model, electrons move in definite orbits around the nucleus, and the orbits or energy levels are located at certain distances from the nucleus. How an atom works has changed dramatically through time, but the atom still continues to define matter at its most fundamental level. We will use this understanding as the foundation for molecular behavior.